Welcome guys, today I'm going to be solving this fun geometry problem involved in finding the area of a lune. So one of you may be asking right now, what even is a lune? I'm going to tell you the lune is formed by the intersection of two semicircles and is the area right here which is shaded, which is outside of the larger semicircle but inside of the smaller semicircle. So here in the problem we have the large semicircle of diameter of 2 and one intersecting it with diameter of 1. And the moon is the shaded region right here, which looks a bit like a crescent moon, hence the name. And we have to find the area of this, where I think I said the diameter is 1 of the smaller semicircle. All right, so usually for when we have semicircles, we can easily find their area. We have the diameter, which means we have the radius. So let's actually quickly do that. Let's have area of large semicircle. It's going to be pi r squared over 2. It's half of a circle. We know the radius of the large one is 2. Diameter is 2. Therefore, the radius is half of it. It's going to be 1. So we get pi times 1 squared over 2. It's equal to just pi over 2. That's the area of our large semicircle. All right, that seems right? Radius is 1, pi. Okay, and now for the area of the small semicircle, we have the radius is going to be a half. We have pi times a half squared over 2. Okay, that's going to be pi over 4 over 2. That's going to be pi over 8. How nice is that? Okay, so now what? The key to this problem is making a simple construction. Let's connect the center of the semicircle O to sides B and A. Look what we have here. AO and OB, they're both radii of semicircle, the large one. They're radii, therefore their length is 1. But look at this. Side AB, which is diameter of the small semicircle, is also 1. This is very powerful. We have an equilateral triangle right here. So now we know this angle AOB to be 60. And then we can deduce, because OD is 1 and CO is 1, and they form a linear pair, that these angles have to be congruent. Therefore, they are also 60 degrees. All three of these parts, it kind of divides the semicircle into 3 sectors. And that's what we have to find the area of, to then find the area of the shaded region. Okay, let's first call the area of the, not gonna write out area, let's call the area of the sector some variable sector. It's going to be A. And let's also have the area of the triangle be B. And finally, we also have to know this intersection of the large and small circles, this little shaded part below the lune. Let's have it be called C. Intersection is going to be C. All right, and this is going very well. Once we find the areas of all of these shapes, we're going to be able to find the area of the lune by some subtraction, by some complementary counting. Okay, let's calculate them. The area of A, this is going to be a sector, is going to be 1/3 of the large semicircle. So it's going to be 1/3 times pi over 2. It's going to be pi over 6. Wonderful. Area of triangle. Recall that the area of a triangle given 2 sides of an angle is by this formula. Let's write it here, like right here, for example. Area is equal to AB sine of C over 2 of a triangle, where sine of C is the angle between sides A and B. And therefore, with this triangle, we can write it out. It's equal to AO times OB times the sine of angle in between them, which is 60 over 2. Let's do that. We get 1 times 1 times sine of 60 over 2. The 1's get removed. We get sine of 60, which is root 3 over 2 over 2. It's equal to root 3 over 4. Wonderful. And now for C, we are actually almost done. We needed to find the area of the sectors in the triangle to actually find the area of this intersection. Because once we know the area of this intersection, we're able to subtract it from the area of the small semicircle to get the area of our lune. And to get C, we have to subtract all three of these things, the sector and the triangle, from the large semicircle. So let's do that real quick. It's going to be the large semicircle minus 2 sectors. So it's going to be 2 pi over 6, pi over 3, minus the triangle. That's going to equal pi over 2 minus pi over 3. It seems like, real quick, it's going to be 3 pi over 6 minus 2 pi over 6 minus root 3 over 4. Yeah, it's going to be pi over 6 minus root 3 over 4. And that's the area of C. And now finally, to find the area of the lune, C remembers this intersection right here. We just subtract this from the area of the small semicircle. And we will be done. Pi over 8 minus pi over 6 minus root 3 over 4. That's equal to, oh, what's pi over 8 minus pi over 6? That's going to be 3 pi over 24 minus, what is it? 4 pi over 24 plus root 3 over 4. And that's going to be, finally, root 3 over 4 minus pi over 24. And that is the area of this lune right here. Going to write it once again, so you will see. And yeah, with some simple construction we made, we're able to find an angle. And through an angle, we can get so much done. So yeah, that's it. Thanks for watching this geometry video.